Hello everyone. Uh, we are going to discuss about what is refrigeration cycle and what is the coefficient of performance in this session. So myself, P. Induja, working as an assistant professor in the Department of Chemical Engineering, Hindustan College of Engineering and Technology. So we are going to discuss about what is refrigeration process. So coming to the next slide. So the introduction part. So what is refrigeration? So refrigeration is the process of producing and maintaining a temperature below that of the surrounding atmosphere. And here the major application area of thermodynamics is refrigeration. So which is the transfer of heat from a lower temperature region to a higher temperature region. And this uh, the device that produces refrigeration is known as the refrigerators, and the cycles on which they operate are called as the refrigeration cycle. So the most frequently used refrigeration cycle is here one is vapor compression refrigeration cycle. So one of the important one, and the gas refrigeration cycle, which is another important one. So here the vapor compression refrigeration cycle, in which the refrigerant is vaporized and condensed alternatively uh, and is compressed in the vapor phase, and as well as the gas refrigeration cycle, is which the refrigerant remains in the gaseous phase. So without any delay, we will discuss about what is the types of compression. That is, one is vapor compression refrigeration cycle and another one is gas refrigeration cycle. Yeah, so coming to the principles of refrigeration. So before going to know about what is the principle of refrigeration, the refrigeration process finds wide applications in chemical process industries. So in chemical industries, the process is used in manufacturing synthetic rubber, and also used in the textile industries and chlorine and the plastics, hydrogen gases for fluorides, etc. So this refrigeration is used to remove heat of chemical reactions and to liquefy process of gases for gas separation by distillation and condensation. Uh, yeah, so this is what the refrigeration process is. And there is a two principles of refrigeration. One is the liquid absorbs uh, heat when changed from liquid to gaseous state. That is also known as latent heat of vaporization. And gases gives off heat when changes from gases to liquid state. That is known as the latent heat of condensation. So when the gaseous state to liquid state, it is known as the latent heat of condensation. And the liquid absorbs heat and it changes to liquid to gaseous state. It is known as the vaporization. So these two is the principles of refrigeration. And going to the process, that is four basic process in refrigeration system. So one is so that is first processes. So first to second stage. So first to second is isentropic compression, that is in compressor process, and second to third stage is constant pressure heat rejection process, that is in a condenser, and third to fourth process is in throttling valve, that is isentropic expansion, and fourth one is 4 to 1, that is constant pressure heat addition, that is evaporator. So there is a four process. One is compressor, another one is condenser, another one is using throttling valve, and another one is using evaporator. So that is isentropic compression and isentropic expansion, and constant pressure for heat rejection and constant pressure heat addition. So this is the four basic processes in refrigeration process. Yeah, so this is the cycle of cooling. So here you can see the low pressure side and high pressure side. So the low side is known as the low pressure side and high side is known as the high pressure side. So it is given in two different colors, that is blue and red. So here the condenser part is high pressure side and evaporator part is low pressure side. And the expansion valve and compression part is both uh, equally given. So here from expansion valve, you have already seen that in the before slide that we have seen that expansion and compression and evaporation and condensation process. So from the expansion valve, that is to evaporator, you can see the low pressure liquid, and to the evaporator to compression process, that is low pressure gas, and compressor to condenser, you can see the high pressure gas, and condenser to expansion, that is high pressure liquid. So these are the cycle of cooling. So from the condenser part to evaporated part, that is the cycle of cooling is done in the refrigeration system. So this is the cyclic process of cooling. Yeah, coming to the compressor. So before going to know about what is compressor, we have to know the what is use of compressor. So here the rounded thing is a compressor. So here the refrigerant comes into the compressor as a low pressure gas. It is compressed and then move out of the compressor as a high pressure gas. So here in the diagram you can see the high pressure gas in red color, and yellow is high pressure liquid, and green is low pressure gas or liquid, and blue is a low pressure vapor. So from gaseous to liquid and liquid to vapor, it is cyclically done. So the refrigerant here comes into the compressor as a low pressure gas. So the low pressure gas, that is in green color, it is compressed and then move out of the compressor as a high pressure gas. So the low pressure to high pressure, then the compressor process is done. So this is the compression, and next one is condenser. So the condenser is in red color, that is high pressure gas. So the gas then flows to the condenser. Here the gas condensates to the liquid and gives off its heat to the outside air. So um, you can see the compressor, and after compressor there is a condenser. So from the liquid is flowing to the condenser, and condenser is used to cool the liquid, and it is sent to the expansion valve. So here the gas condensates to a liquid and gives off its heat to the outside air. And the expansion valve, third one. So in the expansion valve, or we are used to say as a metering device. So in this valve, that is in green color, sorry, green with yellow color, that is expansion valve. So this liquid then moves to the expansion valve under high pressure. So at high pressure, the liquid is moves to the expansion valve, and this valve restricts the flow of fluid and lower its pressure, and it leaves the expansion valve. So here the pressure will be reduced, and it is also given it to the expansion valve in the fourth process, that is in blue color. So in evaporator, so that is fourth stage. So in the evaporator, this the liquid which gets evaporated, and the low pressure liquid then moves to the evaporator, where heat from the inside air is absorbed and changes it from the liquid to the gas. So evaporator used to changes the liquid into a gas substances, and it is sent to the compressor. So this is the cyclic process, and again it comes to compressor finally as a hot low pressure gas. So you can see the low pressure gas is finally comes into the compressor. The refrigerant moves to the compressor where the entire cycle is repeated. So this cycle is repeated in the refrigeration process. This is known as the refrigeration cycle. And vapor compression refrigeration system. You can see the vapor compression refrigeration system, and here you can see that the compressor is here. So the compressor is refrigerant gas is compressed from low to high pressure, and that is sent to the condenser. So top of that is a condenser. The condenser used to help to discharge heat into surroundings, and the refrigerant changes from gas to the liquid. Yeah, so from compressor the air is sent to the condenser, and the heat is producing, the condenser used to cool the air, and it converted it to liquid, gas to liquid, and then it is sent to the expansion valve at high pressure side and low pressure side is there in the expansion valve. And during the high pressure side, the expansion valve separates high pressure from low pressure, and it is sent to the evaporator, and evaporator used to convert the liquid into gas. So this refrigeration turns from liquid to gas in the evaporator. So this compressor, condenser, expansion and evaporation is a cyclic process in a refrigeration system. So this is known as the refrigeration cycle. Yeah, so we can calculate by using the coefficient of performance, that is COP. So COP is nothing but the performance of refrigerators and heat pumps is expressed in terms of coefficient of performance, which is defined as uh, desired output, that is Q2 divided by W, that is work input. So the required input or work input, and the cooling effect divided by work input, that is QL divided by W net input. So this is the formula for refrigeration, that is we are also known as COP is equal to Q2 divided by W. So the efficiency or coefficient of performance of a refrigerant is defined as the quantity of heat absorbed at the low temperature per unit of work. So W is nothing but Q1 minus Q2, and COP is equal to Q2 divided by W, since it is known as Q2 divided by Q1 minus Q2. So this is the coefficient of performance. So since it is acting as a heat pump, so the low temperature reservoir to high temperature reservoir, we are giving the work as an external device. So to selecting the right refrigeration, there are several types of refrigeration such as CFCs and ammonia, hydrocarbons, and also the carbon dioxide and air and even water. So this is the right thing we have to choose about which refrigeration we can use. So which refrigeration type you can use. The right choice of refrigeration depends on the situation at hand. So the industrial and heavy commercial sectors were very satisfied with ammonia and still are with ammonia only. Although ammonia is toxic, but due to its several advantages like higher COPs and low cost and no effect on ozone, so we are using the ammonia as a industrial applications. So this is the refrigeration, how to select the refrigeration. Yeah, so hope you have understood what is refrigeration cycle and what is coefficient of performance in refrigeration cycle. Thank you.